Hi, good evening. My name is Ms. Daigle, and I will be going over representations of functions video with you. Remember that all of this is a review from last year, and you should take notes on the function or not function notes page that you received in class today, which looks like this right here. We will be gluing it in on page 12 of our ISN, and we will be filling out the blue foldable that we set up in class today. Okay, so what I want you to do first is to look at this machine. If you take these numbers that were given to you of 2, 5, 8, 1, -5, -4, if I put these numbers into the machine, can I solve for the output? For instance, if I have a 7, x equals 7, I can plug it into the x value. 3 times 7 is 21 plus 2 gets me 23. So I want you to plug in these 6 numbers and solve for the output. Go ahead and pause the video, solve them, and put in these numbers. Okay, you should have received 2. When I inputted 2, I get an 8. When I input a 5, I get a 17. When I input an 8, I get a 23. When I get a 1, I get an output of 5. When I input a -5, I output a -13. And when I input a -4, I get a -10. This is solving a basic equation by plugging in what we know. Now, my question to you is, what is it called when one output has one and only, what is it called when one input has one and only one output? Very good. It is a function, which you learned last year. So, what we're going to be discussing this evening is how is a function represented and what does it look like. So in a graph, and this is on your function notes, top thing says to determine if a graph is a function, you do what? Does anybody remember? Very good. You use these vertical line tests, and I have a line right here I'm going to use, but if you're just looking at a graph, you can use your pencil, and I drag it across. Right here, there's only one spot touching the graph. Here, there's 2 spots touching the graph, here and here, so therefore this is not a function. If I go to my dots, there's only 1 dot on this vertical line, 1 dot on this vertical line, same thing, 1 dot, 1 dot, 1 dot, and 1 dot. So this is a function. Go ahead and write above this graph that it's a function, and you can write above this one, not a function. Okay, let's go look at this lower one down here. What do you think? Yes, yes, but there's 2 dots on this vertical line, so this is not a function. Very good. And let's look at the last one. 1 dot good, but 2 dots here, so this is not a function. So go ahead and fill in to determine if a graph is a function. You use the vertical line test. Very good. Remember, at any time, if you need to pause the video, please do so. Okay, the next section says to determine if a set of ordered pairs is a function, what do you do? So if I want to look at this set of ordered pairs, one thing I could do is I could sit here and I could graph these ordered pairs. I could make me a graph and say I know at 0, 2, I'll have a dot. At 1, 2, 3, 1, 2, 3, 4, I would have a dot. At 4, 6, at 3, 7, ooh, right there, I notice that I have 2 x values the same, so if I was to draw a vertical line on that graph, would it be a function? Very good. Not a function. So when looking at a set of ordered pairs, what value are you really looking for? The x value, correct. Okay, so I can look at the second set of ordered pairs, 1, 3, -1, 5, and 2. Do any of the x values repeat? No, so this is a function. Very good. Okay, let's look at the bottom set. -2, 1, 2, 3, and 4. Oh, so since it's negative 2 and 2, those are the same, it would make a vertical line? No. And guys, remember that if you're confused by this, go ahead and make your graph. Negative 2, 7, 1, 8, 2, 3. I'm just estimating about where the points would go. 3, 2, and 4, 1. So if I look at it, are there any on the same vertical line? No, so this is a function. So when looking to determine if a set of ordered pairs is a function, look at the x values. If any repeat, it is not a function. Okay, next thing, let's look at mapping. When looking at mapping, I do the same thing as a set of ordered pairs. I could graph these ordered pairs. If I start with negative 2, it's saying I output a 3, so negative 2, 3. If I input a 1, I get a 2, so 1, 2. If I input a 3, I get a negative 4, so 3, negative 4. If I input a 7, I get a 3. And if I input a 5, I get a 6. So really looking at this, do I have any that are repeating on the same vertical line? No, I don't. So this is a function. So same thing as the ordered pair, or the set of ordered pairs. I'm sorry. Look at the x values. If they are all different, then it is a function. Okay, but now let's look at this mapping. To me, negative 4, 3, 2, and 6 are all different. But write them out. If I have negative 4, if I input a negative 4, it's going to output a 5. If I input a 3, I'm going to output a 4. If I input a 2, I get a negative 2, but also notice at this 2 that there's a second line coming off saying if I input a 2, I get a 7. And if I input a 6, I get a 1. So even by looking at it, all numbers were different. I noticed that this 2 had 2 lines coming off of it, so it was 2 different ordered pairs. So do I have 2 values with the same x, or 2 ordered pairs with the same x value? I do. So therefore, this is not a function. So when looking at mapping, determine how many lines are coming off each number. On our first set, all different numbers, 1 line coming off of all of them. Second set, all different numbers, but this 2 had 2 lines coming off of it, so therefore it was 2 different ordered pairs. Sorry about the bell, guys. Okay, and in the last one, I'm going to look, are all the x values different? They are. And do I have 1 line coming off of each number? I do, so therefore it is a function. So in a set of mapping, again, you look at the x values. Are they all different? And is there only 1 line coming off of them? Okay, and then the last set, we're going to look at a table. Again, guys, just like the set of ordered pairs, table is very simple. You look at the x values. Negative 8, negative 3, 0, 2, and 5. Are they all different? They are, so it is a function. Let's look at the next one. Negative 1, 2, negative 1, 6, and 7. I notice right here that I have negative 1 twice. Now, if I was to graph this at negative 1, 3, and at negative 1, 7, they are 2 different points, so therefore I have 2 points on this vertical line, so therefore this is not a function. What if I looked at it and said negative 1, 3, and negative 1, 3? That would be the same exact point, so therefore it would be a function because the dot is on top of each other. You only see 1 dot. Okay, and what about negative 1, 2, 3, 6, and 7? They're all different, so therefore it is a function. Very good. So again, to determine if a table is a function, we look at the x values. If they are different, it is a function. If there are some that's the same, we need to look at the y values. Very good. Okay, and the last thing we're going to look at is a situation. How do I determine if it's a situation? Think about it in real world. The cost of a car and the color. If I buy a $20,000 car and it's red, can I still buy a $20,000 car and it be blue? Absolutely. So, do these two things have anything to do with each other? No, so it is not a function. Okay, think about pencils. They're 40 cents per pencil. If I buy one pencil, it will be exactly 40 cents. If I buy two pencils, it will be 80 cents. If I buy three pencils, it will be $1.20. So no matter how many pencils I buy, will the output be different? Yes. So therefore, this is a function. And the last thing, my foot size and weight. Can somebody have a size 5 and weigh 80 pounds? Yes. Can somebody also have a size 5 and weigh 120 pounds? Yes. So does your foot size and your weight have anything to do with each other? No, so this is not a function. Very good. So to determine if a situation is a function, build a table like I did with the pencils, or think about it in real-world situations. Okay, so that is all for our function or not notes. Let's go ahead and look at the blue foldable that you put together today in class. On this blue foldable right here, you have a table, mapping, equation, and graphing set. So what I want you to do is take this equation of y equals 4x plus 2, write it in your ISN under the equation tab. Then I want you to build a table using the points of -2, 0, -1, 1, and 2. Build your table. Take those points, map them, take those points and graph them based on everything that you did on your function or not a function notes, and we will check this tomorrow in class. Thank you. Have a great evening, and do not forget to do your whisk underneath the notes that you glue in on page 12. See you tomorrow.